All right. No worries, Phil. Thanks a lot for inviting. Okay, so let me quickly share my screen. Um, so today we are going to be doing a reflection on community building because it's not going to be a technical session at all. It's mostly around like what Tel just said, what we have been doing, and what's the underlying principle on which we are doing all these things, right? Because with respect to any new technology, when it comes out into the market, there are like a lot of interest in the beginning, then there's a lull, and then when something big happens, then the industry takes off, right? Um, but the point is like events happen, then like sporadic sessions would be happening, but there won't be like a clear strategy or a path behind it, right? We have seen that with blockchain. We have seen that with like early stages of internet. So with quantum, what can we learn, or as a community, what can we learn from these previous, patterns that we have observed in terms of technology adoption, and how do we try and create something that's sustainable, that is long term, right? So that's the thought process in which this is being built. So as a community, it's not just focused on technology because more and more we are getting into a systems-wide thinking based solutioning in the future, right? So there's always going to be multiple streams coming together, and quantum is a space where that's actually happening because it requires that also. So it's not just tech. So we are building a community of quantum enthusiasts, right from pure science to art. Like storytelling becomes important as well. So that's one stream, though we haven't started doing a lot in that direction, but eventually we'll get there. So tech, art, pure sciences, and policy as well, because this is something that's going to have larger implications on the society. So regulators and regulations has to be in place. So we as a community has to be the feelers of what's happening on the ground and nudge or point the people in authority in the right direction, right? So that's also a morality that we as a community are trying to have for ourselves, right? Like hold ourselves to that standard. So, okay. So quickly, we are going to talk about first what are all the things that we have been doing, and then we'll get into why we are doing what we're doing. So as a community, so it's a learning community. So that's something that we have to be clear about. So there are support groups, multiple communities happen there, like performing arts thing. But if you broadly classify it as something, like skill-based communities where quantum computing falls into, right? And then there are space-based communities, language-based communities, activities-based communities, right? So we are focusing on skill-based communities. So if you're trying to inculcate a skill and grow that skill over a period of time as a community, then of course, like you should be at the cutting edge of knowledge, like understanding what's happening and then translating into a way that's where the art form comes in as well, like storytelling comes in, right? Like translating it into a way that the wider audience understands this, and wider audience in the sense of from research, then you have to convince business because there should be a use case. So again, that's one type of storytelling with business. Then you have policymakers, that's another type of storytelling. Then with the people who are going to be building these products and solutions, so that's another type of story. So it always is a multidisciplinary stream, right? So knowledge series is an umbrella under which we have two different streams. So one is facilitator series where experts essentially come and share their knowledge with us. So like we have professors like Science Srinivas. I mean, we have done IIC professors, all subject matter experts, then industry experts, right? So all different types of people, not just academia, all different types. So that falls under facilitator series. Now, there could be, sporadic events also that we do, But uh, so we're talking about the learn part, right? So there could also be the themed aspect. So this is where it gets a little interesting, because this something that we did in August, right? So the entire August was dedicated to just learning about cryptography. And so then it kind of gets into co-creation. I'll get to that. So right now we are talking about learning, which is knowledge series. We talked about facilitator, and now in facilitator, it could be sporadic events or it could be a themed session. So in August, we did cryptography, understanding the basics of cryptography, implementing that, then slowly getting into quantum, then post-quantum cryptography, then a couple of shorts algorithm kind of things. Then so till now it was more like literature review, right? And then we kind of brought in academics and professionals like Dr. Urbasi from RRI, Raman Research Institute, and Dr. Anandita from CUNU Labs, right? So this is to talk about like where the research is heading, the cutting edge research is heading, and what the industry is doing. It was kind of like that. So literature review, then understanding what the industry is doing, understanding where the research is going. So once we did that, we kind of formed ourselves into smaller teams to continue the learning into a full cycle, which is through co-creation, right? So as a community, the three very base value props are there, which we just talked about, which is the knowledge series part, right? Facilitator, then themed and non-themed as well. Now, peer learning is something that we kind of stumbled upon because we had like 20 apprentices joining us in August, and we were putting them into smaller teams of cryptography, finance, quantum machine learning, and even devices and hardware part, right? So this kind of became like a directed outcome for our 1 week of learning. So we meet every day 10 to 11 p.m. each of these smaller teams, and then we have a clear roadmap of what we are going to do for that week and a proof of that learning, because it also motivates us to say, hey, this Sunday we are having a peer learning session, right? And this is way better than the traditional modes of teaching or learning as well, right? Even most universities are going this way, where the teachers or professors are becoming more like facilitators than the stand and deliver kind of methodology. That's changing. In India, also it's changing, but it's going to take some time. But peer learning has accelerated our learning based on the feedback that we have gotten from our community members, right? So peer learning, so like I said, Sundays is when we have the peer learning session, where each of these teams that are working for the last 1 week, they come and concisely give their learnings for that week. So learn now essentially comes from experience and professionals and from the community itself. Now, once this learn is happening, what's the role of the community here, right? So that's where the first tenet comes into play, where what type of community are we building? Now, because it's a community, which means like there's no standardization in terms of who you're gonna let into a community, unlike colleges, unlike schools, right? Where like you're put into the same age group first. First of all, that's broken in a community. Like there are people with like 16 years of age all the way up to like 65 years of age, right? So respecting students and the experiences that comes with their age, the economic background that they are brought up in. So all these things has to be respected. And so we put all these things into an umbrella term called safe enough spaces. The reason being, which ties back to the first thing that we talked about, which is QCI is a skill-based community, right? So it's a skill development and a skill movement community. So for you to develop a skill, it has to be a safe enough space, not a purely safe space. A safe space is good for therapeutic things, right? Like Alcoholic Anonymous, AA meeting, like that should be a safe space where like purely no judgments, right? Whereas when you're trying to develop a skill, there should be judgment. That's one of the reasons why we have, your questionnaires and your grading systems and whatnot in the traditional educational systems. So how would a community react to that, right? What's the tool set that the community can use is essentially the work that they'll be doing, right? Which is what the third part will come to. So first is mutual respect for everyone in the community, and then reflecting and analyzing complex thinking. So now this is tied to the peer learning sessions, because the 1 week of learning that has to be concised into 15 minutes of presentation, right? Because it's just 1 hour, 1 to 2 hours we do, because there are 4 teams and it's 30 minutes each team. So what happens in the entire week is everyone reads different white papers or different research papers, or someone is implementing a certain algorithm. And then when we meet for that half an hour to 1 hour every day, we are essentially pushing each other's thought process and ideas. And that way the learning accelerates. For example, in quantum cryptography, we have a PhD student, Mahima. She has given a talk at several sessions. There's, Archit, who's like a pure science, then like Nilay and Kedar are interested in devices and network level thinking, and then Vaibhav kind of implements this, right? So this kind of team, for you to set it up, think about the frictions that a person has to go through, right? But in a community setting, it can happen provided we set the environment for this to happen, right? Organization structures, you can think about it that way. You can think about it from innovation perspective, and like how always putting people of different age groups, people of different backgrounds, people with different ideas together, belief systems together, always leads to accelerated innovation, right? And community is the best place to do that, because like we said earlier, there's no gate, right? Like we are not saying, hey, you have to write an exam to get into it. So that's not the way. So which means everyone is there. And then all the community managers has to do is to create this space where this collaboration of ideas can happen, right? And peer learning also gives the opportunity to take more risk wantedly, because the name itself suggests. So when we say Sundays are peer learning sessions, not just the community, to the public also, we put it out very clearly that, like we are no way experts here. It's a log of a learning. And when you look at it from that perspective, suddenly everything changes, and then like people start taking more risk, right? So that's also one of the tools that kind of promotes accelerated learning spaces. All right. So now, these are all theoretical things. So how do we actually practice that in building a community? So any space where people are put together, be it a classroom where like physical people are sitting, or groups like WhatsApp, Zoom. Like this is a live session, so there should be the same principles applied to any of these digital spaces as well. And the moment we start looking at things like that, then automatically the communication changes, the way you design your poster changes. Everything flows together the moment we understand what we stand for as a community, because our job is to just set the space and see how these ideas are going to merge and create something beautiful, right? So that's a great segue to talk about the third aspect. So you have set the space where people are coming and they're learning, but learning has to, because we said like there's no exams and stuff in a community space. So the best way to understand a person's skill level being increasing or not is by co-creation, right? Now, co-creation, this is taken from MIT's design thinking lab. So co-creation, this is more from media side, but it applies to even technical communities like ours, because it kind of questions or breaks this notion of a single author vision, right? When multiple people come together. So like I just gave an example of quantum cryptography. So similarly, we have quantum finance vertical, where Pawan, who's a subject matter functional expert, now he comes with a background of quant trading, building and architecting large-scale technical solutions for like Infosys. So he comes with that background, and then there were people like Samruddha, Anand, Sayantan. So these are people who come with Qiskit and quantum computing implementation and Qiskit, and then so when you put this team together, now we are trying to work on a very interesting problem, which Pawan will explain in a bit. And then third is quantum machine learning. Though we haven't reached the use case level yet in quantum machine learning. We are still in the phase of doing the literature review phase, right? So now the very interesting thing that's happening is this is all still very, a little broader, and like people are still seeing use cases over here, right? Like across the globe, people are trying out different things, especially in quantum cryptography, the way things are accelerating, because unless you break the existing systems, like no one is going to take quantum cryptography seriously, right? Like that's one of the reasons why people say oh, I don't see it happening. Like, where is it happening? Like, what is quantum? The mainstream hasn't caught up to this yet because such the existing cryptographic algorithms haven't been broken yet. And the moment it happens, right? So who's going to get there first is a question. Like countries are investing billions into that. From our side as a community with people loosely associated mix of people is essentially a community, right? So in that environment, how do you try and push this co-creation becomes a challenge. That's what the next block is going to be about. So of course there's going to be a risk, right? So because there's no incentive structure in place yet, right? But so what would happen in that case, right? So the problem is there's no time commitment in the sense, like in terms of hours, of course, but then like if the output isn't there, like there's no way for you to unless the person themselves understands the importance of that. And that's where I think the trust and like the understanding the values that the community stands for comes into place, because if one person falters, then the entire project kind of slumps down, and that kind of creates to some extent collective responsibility as well. And to some extent, if you're not pushing it, so one way that we are optimized or we have kind of solved that is by having daily stand-ups, right? So you can clearly see the team that meets every day, the team that sets a vision for a week, and then assigns tasks to different people based on the interest, right? That team usually goes faster. And so now it's just a matter of time for the other teams to see that the process that has been set by this team that's moving faster to operationalize within their own teams, right? So that's part of the best practices that I talked about. This could be a little abstract, but like the really actionable thing is essentially setting process around communication channels and process around division of labor, and having a tool to make sure this all happens, right? So one thing that has been working great for us is this tool, which is called Roam Research. It's essentially a note-taking tool meant for personal knowledge management, but we are kind of using it for community management by again setting processes and checks also. Yeah. Okay. So we have talked about the three tenets of a skill-based community, which is meet, learn, and create. If you really look at this, all these things comes on one side of the coin, which is the supply side. Now, before we get into why the supply and demand side of thought process, it's It's important that we quickly understand what we are trying to do on the demand side, right? So in one side, you're learning, and you're creating also. So now, how do you monetize that, right? Like, because it should be a sustainable community at the end of the day. So there are two ways that we are thinking about. One is at a broad level, this will become like an IP holding company. Now, this model essentially comes from what I saw at National University of Singapore. They have a unit called A Star. Now, A Star is nothing but an IP holding company that holds the IPs of all the PhD student and the research work that comes out of NUS, irrespective of the school within NUS. Right? Like the NUS has an engineering school, they have a public policy school, business school, art school, everything. So irrespective of which school the IP is created, this holding company holds it. But that's not necessarily a bad thing, right? Like they're holding it because they know how to monetize that better, right? Like they can bring the resources together to monetize an IP, right? So one, the way traditional institutions can create this is because PhD students are there, IP is being created. So traditional institutions can easily create that. But as a community, how do you create that, right? Like that becomes a challenge. So so it's still in exploration process, like because we haven't reached the stage of any remarkable IP. I mean, we are close in terms of two areas, but yeah, by the time we should have more clarity on this, right? So, so the IP, so one way is you create your own IPs, right? That's where this quantum finance and quantum cryptography team are rushing towards. So that becomes the IP of the community per se. And the second thing is IP commercialization. Now this becomes very interesting because this may be traditional institutions may not be able to do, right? So being a community or a loosely structured thing also gives you this flexibility to try around multiple things, right? So IP commercialization for existing IPs, because we have this supply of quantum enthusiasts who understands different fields, then what you can do is take these IPs, make it or break it down into a way that the industry would need it, and then build a team around that, right? This is typically done by VC firms that are way ahead of their curve, or like that is giving way better returns than most other VC firms for the GPs and LPs, right? So one is Lux Capital, LUX Capital by Wolf George, right? So he came to prominence by essentially doing this. As an investor, what he would do is he would go and pick up, he'll be like scoring through research papers, like because he wants to be at the cutting edge of research, because that's where commercialization happens, right? So he looks at the research and then he reaches out, like if there is something from his, the market mind is able to figure out something can be commercialized. He goes, brings that scientist out, creates a team around that and invests into that. And then that's one of the reasons why his success rate is way higher than other traditional VC firms, right? So this is something, so now we are at that stage itself, right? As a community, you are right there where this cutting edge innovation is happening, because you have people from different universities coming and being part of the same community, right? Where people from different ages coming, people from different countries coming together, right? So a community is a great way to leverage that, right? The moment you see some IP, you see a potential for a particular IP available, you have the bench strength, so to speak, which is the supply of skills that you have created over a period of time, right? All right, so that's on the demand side. So these are the two things that we are thinking about. And so we talked about on supply side, as in like building a skilled workforce around quantum. We talked about facilitator series, peer learning series under Learn Tenet, and then we talked about how the communities should become the space where these collaborations can happen and what are the best practices over there. And third is to complete learning, you have to co-create. We talk about that. So now you have this side sorted. How do you make sure that this is commercialized so that the supply of skills that you have created makes sense, right? So that's what we talked about in the demand side. Now, where is this coming from? Why do we have to look at a community from the angle of supply and demand? That's the next set of topics. Before that, okay, how do you monetize your efforts? I'll answer that in a little bit. It'll kind of be small. Yeah. All right. Cool. So we keep throwing around this word community, community, community. What does it mean? A vague definition is a bunch of people coming together, right? That's a community. But if you dig a little deeper, then it can be positioned very differently, which is what you see over there. This is from a book called The Third Pillar, written by Raghuram Rajan, the ex-RBI governor. He talks about communities becoming the third pillar essentially, which is a balancing act between the state and the market, right? Between the government and between the business side of things. So then, but most of his book is around space-based communities, right? Which is what we're going to talk about next. So if it's going to be a balance between the state and the market, how can a space-based community become that? One way to think about, at least in India, is the ward number. The ward number is the most atomic piece of Indian governance state-wise, right? So at a ward level, if you can create a community and then make it run like a small government in itself, which means the ward will start thinking about the people over there, how can we upskill them, and then creating a marketplace for them, okay, at a high level. That's the framework that Raghuram Rajan has given in the book. And it makes sense because then decentralization of power is happening, which is a good thing in a democracy anyway, right? Okay. Skill-based is what we are concerned about because that makes more logical sense, and from a very positive macroeconomic angle would be, if output is a function of capital, labor, and productivity, and we have over leveraged the first factor, which is capital. If you talk to Pawan, he would say options and futures market is nothing but gambling, right? Like there's no better way to put that. It is gambling, right? So we have over leveraged capital to the extent of saying, hey, next week or tomorrow, I don't know what's going to be I'm betting that this is going to be the price of this commodity, right? It's not even produced yet. And they are already thinking about the price of that, right? Over leverage of first factor, capital. Then comes the labor part. So the one way to balance state and market is to essentially make this labor component become part of the mainstream discussion when it comes to overall economy, right? So skill-based communities becomes pertinent. That's the link that I'm trying to create, right? So if community is a link between state and market, a skill-based community can be the balancing act way faster than a space-based community, right? And then, of course, then we talk about language-based, blah, blah, but there's no, that in the way that we are looking at it, right? Like this is not a generalized community definition that we are trying to arrive, right? So we are trying to arrive at a definition that makes the largest impact and makes the most sense to us also, and which doesn't break the chain of logic, right? Okay, so skill-based community. So that's why I'm very concerned, or like I was spending so much time explaining that why QCA is a skill-based community. That's when this whole structure of looking at it from a supply and demand side would make sense and would make practical and logical sense also to show that there is a sustainable path of it, right? Okay. So the high level framework, because quantum is one type of skill that can be created or looked at both from supply and demand side. So what's the high level framework? So the high level framework is this, right? So on supply side, there's an unskilled, wait, let me show a diagram. Okay. So on supply side, a community acts like an educational institution, okay, where we take in unskilled people and semi-skilled people. So unskilled people are essentially learning through the theory part, which is what we talked about in terms of facilitator series and peer learning series. And then they also get to work on the practice what they are doing, right? That's where the first batch of apprentice that we took comes into picture, right? But semi-skilled people, let's say, already I've published a paper, or I'm like completing my PhD in quantum. So these are skills that semi-skilled professionals. So they will essentially be acting as the performing side or leading a team, right? Which is what is happening in crypto, which is what is happening in finance within QCI, right? So this is on supply side. So we have built this entire thing, then which I quickly showed in terms of demand. So the IP commercialization essentially means you have performed something, so you have created something, IP can be commercialized. That's one way. The other way is IP creating itself. Now, not necessarily these are the only two ways, right? Like you can always start the consulting firm, which essentially acts like, okay, you need a quantum architect, like we'll be in a position to engage, or like a community member is there, and like you can engage them on an hourly basis, right? So that way, what happens is that the community itself becomes a self-sustaining thing. So one question that could come now is, what's the legality of such a community structure, right? Now, this is something debatable. Like there's no one way to legally register a community, so you can either do it like a membership-based cooperative society, and there's enough research again that's going on around cooperative societies are way better than for-profit, the traditional for-profit method that we have been following, right? So there's platform.coop, COOP. Please check it out. It's by a professor from New York. He has started something called newschool.edu as well. And they are essentially trying to create this platform for all these cooperatives. Right? Cooperative is one way to register. Directly as a public limiter is another way. There's actually nothing stopping people from registering a public limiter. The reason why these two would make a lot more sense for a community, because Amol also asked a question about how do you monetize your efforts, right? So the members has to have something. One, the community has to be beneficial for them in terms of the space it's setting up for them, the learning spaces, the creation spaces. That's one thing. But apart from that, now we are also bringing in gigs and other things. So the moment these transactions start happening, providing other financial services like access to loans, credit, and whatnot, which are typically not available to a gig worker, right? Because that's why membership becomes important, because now you become a community or a collective of people, then your bargaining power increases, so you get the same credit cards, whatnot. Okay, so that's one way to look at it in terms of legality. But yeah, we'll like everything, we'll figure it out as and when we need to figure it out, right? It'll happen. All right, so it's 8:11 now. I just have two quick things to talk about. This is also part of this larger research, the fellowship part, because the apprentice who joined us learned, started giving peer learning sessions, and now what's the stage at which they can become a facilitator, right? And then if they are becoming this if their skill level keeps increasing and they're becoming some peer learning session givers to facilitator session givers, then the community has to compensate for that. And where is that money coming from? Then that money is going to come from the courses and the fellowships, right? So this is one thing. This is the first time we are going to be showcasing. So fellowships is one way. So this is purely for beginners. This is also will become this path for people who are starting quantum at zero, level zero, very interested. I've read like few books around quantum computing, few fiction books, probably, so for beginners now, this will become a very clear path. Like what we are planning is 6 months of foundational classes. Sorry, not 6 weeks of foundational sessions. So these are the sessions that you see over here. And then 6 weeks, because now we have this nice 3 verticals, or one is a horizontal, 3 segments that are going on within QCI. The next 6 weeks, these people can now join one of these streams, right? So that's the specialization for the next 6 weeks. So your finance, cryptography, or machine learning. And then all right, great. So Pawan is here. So I'm going to quickly ask Pawan to let us know about what's happening in quantum finance. Pawan?
Yeah, Sam, thanks. Can you hear me?
Yeah.
Cool. Guys, hi. My name is Pawan. I am part of the Q Finance team within QCI, the Q Finance track. So currently we are working on a very interesting problem. We are trying to build a portfolio of options in such a way that we can take advantage of the volatility, expansion and contraction, right? So essentially trying to find a scenario where the prices are too stretched, and then see if we can take advantage of it and trying to generate some good returns out of it. So by using quantum finance, what we're trying to achieve is we're trying to build a portfolio that would have never existed in the past, would have never been discovered by classical computing. Because as you know that there are various combinations possible, right? So if you're working with, let's say 15 stocks, there are thousands and lakhs of combinations possible portfolios that you can build and take advantage of. And using classical computing, it is not really possible to go over each and every portfolio and evaluate its suitability or fitment or profitability. So by using quantum computing, that kind of a problem is now solvable, and right, and we can now discover portfolios that people have never seen or thought of would have existed in the past. So that's what we're working on currently. We have just testing the first phase of what we're doing, and we are actually interestingly we are trying to work with more number of qubits than that are actually available with IBM computers or quantum computers, right? Obviously, because we are looking at large portfolios like 15 stocks, 20 stocks, and the number of qubits that is probably available is only between like 5 and 14. And that too, 14 kind of qubit machines are pretty busy. A lot of people need that. Trying to figure a solution of how we can do this by using, like, say, 5 qubit computers or qubit computers or quantum machines that are free at that point in time when we're trying to do a job. So we're working on a technical solution which splits the whole task into multiple pieces, submits it to multiple quantum machines, gets the results back, then again puts everything back together and then gives up a response. So that's where we are right now. We have started off with working on the stocks which are underlyings of options. I know some of this might not make sense to some people. I mean, if you do not have the finance background, so obviously things like underlying options are a little difficult to understand. But what I'm trying to say is that the phase 1 is a very basic version. We're trying to get started with a very, very small version of what we want to achieve over a period of time. And then hopefully in phase 2, we'll be able to do much more exhaustive job using options. So our team, we have 3 people, myself, then there is Samrudha and there is Rolf. The 3 of us work together. Obviously, this is a community initiative.
Awesome.
Yeah.
All right, great. Thank you, Pawan. Huh. So,
That would be any questions if anybody has at any point in time, especially relating to Q finance track.
Right. Yeah. Yeah. So the point of this fellowship now is to let people understand. So in these 6 weeks, they'll get to know about the functional understanding of what we are trying to do, options portfolio optimization. So you have to understand Black-Scholes algorithm, those kind of things will happen in the first 6 weeks. And then also whatever we have implemented using classical computing, then the simulation that we are doing right now, that will be taught as well. And then they will continue to become part of this team, right? Like that's the idea. And that's the path that they'll be following, right? And cryptography team, Nilay or Achit, do you guys want to talk about it quickly? Or you want me to? Nilay, Achit?
Yeah, Sam. Yeah.
Yeah.
Hello.
Yeah.
I have a query on quantum finance.
Right. Yeah. Great.
Actually, I know a little bit about option pricing and how can quantum optimizations like amplitude and phase modulation can help in estimating Monte Carlo simulations over uh, quantum option pricing models. Like there's a Black-Scholes-Merton model and there's a Black-Scholes model. So usually in quantum computing, we use Monte Carlo simulations for imitating the Black-Scholes model, if I could sense. So my question here is, yeah, so my question here is, you said you as of now we are trying to use the free hardware and dividing it into the modules, and then we'll use the batch processing to get the output of the result. So what model are we exactly using? Are you exactly using to model the option pricing solutions?
See, right now, like I was saying, right, in the first phase, what we're doing is we are building portfolios of the underlyings and not the options themselves.
Okay.
Okay, so it's a Markowitz portfolio right now, which is of the actual underlyings. Eventually, what we'll do is, to answer your question, what essentially we're going to do is, we will use Black-Scholes-Merton formula to figure out the prices of whatever options we are dealing with. And then we'll use the IV contraction and expansion parameters to define what kind of trade we want to place using the specific option.
Okay, but how would you hold the history of the IVs? Like, if you are predicting the new IV, are you using the old history of the IVs, like some kind of database?
We are not predicting any IV. What we are doing is we are going to find out, we are going to calculate the IV using the BSM formula. So the price of an option is available. It's a fact, right? There is no confusion about that. So using all of the static parameters, we calculate the IV and then we figure out whether the IV is too high.
Okay. One more question
I had. We use various parameters. I'm sorry.
Pardon? Yeah, you were speaking. Sorry,
I was saying that we figure out whether the IV is too high or too low, and based on that we decide what kind of a trade that needs to be taken. Essentially, this becomes a mean reversion trade. If it is too high, then we place a bet saying that it's going to come back to a normal state. If it's too low,
support and resistance. Okay.
I'm sorry.
There is a concept of support and resistance in finance. The base lower bound becomes the support, the upper becomes the resistant.
True, but that's not what we're trying to do. That's more technical analysis. This is more on the quantitative approach.
Okay. One more query I had. Can you just suggest me, like, if someone wants to do the masters in quantum finance, like with the background of computer science, so which university has this, is popular in quantum finance or doing research in quantum finance currently?
Sam, do you want to take this question?
No, Daryl. I think Daryl can answer better.
The question.
No one is doing that, and that is something that I would imagine would probably come up within the next 3 or 4 years. What not to go off on a tangent, but the academic environment moves much slower than the business and technology environment. So it usually takes a professor a year or two to even get a new course approved in a university. And right now, quantum has really not hit mainstream finance, and a course like that generally would be coming from the business school or finance departments. So no, absolutely not. No one is even close to that. Right now, most quantum degrees are either in pure physics or in engineering. We're working to solve that, though, or resolve that.
What Terrell said, in fact, so I am currently a quant trader. Okay, and who was asking this question? Sorry, what's your name?
My name is Prakhar Singh. I work in Bharat Petroleum. Yeah.
Okay, Prakhar. So essentially, the quantitative finance, which is a field that has existed for at least maybe about 15, 20 years now, also does not have a qualified master's degree yet.
Okay.
I mean, not a popular course, you know. And the primary reason for that is that whether you look at quantitative finance or whether you look at a kind of a master's in quantum finance, these areas need the students to be expert in both technology and finance.
Okay.
And that's not something that you come with, you know, with your graduation. You don't come up with, you don't evolve into somebody who has expertise in both, right? So that becomes very difficult to build courses like this, where you need to be an expert both in domain and also technology. So that could be one of the challenges that quantum finance will also face probably in future.
Okay. So if what is the practical timeline of getting an enterprise solution in quantum finance, say a web portal, which can give you the a stocks price based on quantum calculation, online Black-Scholes-Martin model based on quantum calculations? Any just I was asking this question.
See, I don't know if I understand your question correctly, but something like a web portal probably is not the right use case for quantum, you know, computing kind of a scenario. Quantum computing, as I can imagine, especially on the finance side, is going to be mostly around the backend part. So if you understand the architecture, you'll have front end with their backend, right? So most
my point was, see, as usually you can see in the stock websites, you have one calculator. In the background, it used the Black-Scholes-Martin calculations, the Greeks and all.
Right.
IV, it predicts the IV as well. So as as even papers have been published in which the IVs has been calculated using quantum algorithms. So that was I was on the line. By when we can expect an enterprise level solution based on this?
Yeah, I think if people like you join our community, we can probably do that much. You know, we can probably. We are already working. We are pretty in advanced stage, you know, as compared to anybody else in India. But we just lack more volunteers like you. So think about it. If you really want to make a difference, please come and join us. We will together deliver an enterprise level solution.
On the website, I have to send the request.
Yeah, you can get in touch with us.
Okay, thank you. Thank you.
Yeah, that's a great point. You could look at these voids in things that you're asking about. You could look at these as voids that are either a problem or an opportunity. And I think the message is in quantum, most of these voids are frankly opportunities. You know, some of them are very difficult to satisfy, but they're opportunities for an individual or a group of people or a team here in QCI to really step up and fill that void. There's lots of low-hanging fruit out there. This is Terrell again. I also put into the chat a link to the only professor that I know of that is working with quantum computing in the business schools of the university. Not to say he's the only one, but he's the only one that I know of in my you know, scanning the environment constantly. That's the closest. He's more into operations research, but you know, that's as close as we're going to get right now to what you were asking about.
Thank you.
Guys, I'm interested in quantum cryptography and QKD. So I attended some sessions like webinars on QKD. BT is working on QKD and other stuff. But so what do you think? What is the start? Is this fellowship is the first point where I should start, Sam?
Yeah.
Okay, thanks.
Okay, cool. So yeah, quickly, so the quantum cryptography team, our goal is to break RSA, but right now, I mean, we have to take baby steps. So we are in exploring multiple ways of one, optimizing shorts algorithm, and two, also finding out if there are other ways to do factorization better. Okay, that's at a very high level. That's what we are doing. Quantum machine learning team, like I said, we are still in literature review space. Raj, correct me if I'm wrong. Raj is not here. Pinaki, correct me if I'm wrong. Okay. Huh. Um, yeah, so we are in that phase of learning, but like this one use case that we're thinking about, which is video analytics, real-time video analytics. For sessions like this, right? So when when I'm speaking, and then like if other people have their cam on, and what's the emotions, and so that's one of the use cases, because there's one of the other communities that we're doing. We do a lot of these live streaming sessions, and now it has become a norm. That's one of the areas, and probably because I've worked with one of the smart city projects in India, and we were trying to take the live traffic cam feed and then bring it back to the command and control center and do. So the most of the processing was still happening at the command and control center, right? So there was always a delay, and like the percentage was like 80% accuracy was like the best that you could get to. And even then there are like multiple problems. So I clearly see there is some kind of use case in live stream video analytics using quantum machine learning. Yeah, that's probably something that we'll work on, but we are still in the phase of learning. Okay. All right. So this is put up in our page, which is fellowship. Now, next point is the most interesting thing, which is which kind of goes to what Tel was saying, right? Like, educational institution takes like 2 years to, approve a course. And by the time, I think the world would have moved faster, right? So let's say you are on the market side, okay, and you want a person who is good at multi-physics simulation using quantum computing. Now, how will you go and find that person, right? If you're waiting for someone to come out with a course, a master's course, and then like people go there, apply, study, finish, and then by the time you apply, by the time they come to your company, you probably would have gone on to a better idea, right? So again, so communities become a better option here, because the flexibility now that we have is because, of course, the other things still remain the same, which is multiple people, multiple backgrounds. If we can take them through a process of what we exactly need from a person, right? So this process in itself shows how much work ethic a particular person has. That's one of the greatest things, right? Like right now, the kind of people that you see on our teams are people who have been consistent for the last 3 months. That in itself is a testament to the virtues that like people stand for, right? So that kind of becomes a filtering mechanism. So we are going to apply the same thing here. We'll be working with Boson QSI. Boson QSI is going to be one of the best startups in quantum coming out of India, at least. What they're trying to do is essentially simulate computational fluid dynamics based simulations way faster. Okay, for example, let's say you're going to simulate all the particles around the this flight to measure the aerodynamics or whatever of this particular structure. Then it takes close to 2 to 3 months for a supercomputer to come out with one simulation output, right? So when Abhishek, who is the founder and CEO of Boson QSI, was waiting for his simulation to happen, his dad was like, "What are you doing?" He's like, "I'm waiting for this." And like, "What else is happening in your field?" And then he told him, there's quantum which can accelerate this computing and stuff. So dad was like, "Why don't you bring these two things together?" And that is essentially the story behind Boson QSI, right? And he has like amazing team of people, PhD students. So the first 4-5 weeks will be around imparting knowledge to our community. Now, these will be for people who have like completed their Quiz Summer School and stuff like that, right? This is for a little advanced people who understand the tool better. Now we are trying to find the use case, right? And this sounds like a very interesting use case because it brings in multi-physics, right? Like, and now that you bring in computation also. So it's like proper multidisciplinary thing. And it's 5 weeks of this. Then we'll give one problem statement, and the winner of that essentially gets a job offer from both on QSAT, right? Recently, A16Z wrote an article around this, which is deep integration of the job market. And we are actually doing that, right? So this again starts in November. So fellowship also starts in November. So these are two big announcements that I wanted to give. All right, Terrell, overshot by 2 minutes. I'm sorry about that. Meanwhile, guys, if you have any questions, we'll like take in for like next 60 seconds, probably.
Yeah, Sam, you're off by 2 minutes. Shame on you.
Shame on me. But you started 5 minutes late.
Okay, just, as noted, and we had some good discussion, which is a chaotic but good event in time management. But time's not the most important thing. Any questions or comments to Sam?
Or the entire team, yeah.
Well, I've got one. So if you think of QCI as, if you take a look at the marketing funnel, right? How are you, so it looks like QCI, you could think of like a funnel. You're taking raw talent, raw energy, and turning that into, careers and possibly money, et cetera. What are you doing, if anything, to introduce people to the QCI, to the top of the QCI funnel? What's attracting? Because you get a lot of people.
Oh, okay. Well, so the market was paying me for my job, which is head of growth. So I've written a book called the Growth Engine Handbook, right, where we talk about purely from content marketing perspective of doing a lean canvas for your startup all the way up to putting out content buckets, right? So there's a strategy behind, or there's a framework behind all the content that we push out as well. So there's a reason why QCI's page has memes around physics and quantum, right? And the learning series again gets broken down into shorter videos. But for me, I think the real thing is the value addition that people see in this, especially the apprenticeship thing, because the first set of apprentices who really stuck with us, they really appreciated the fact that we have daily stand-ups, right? Because you get interested in something and then your interest level drops. And as a community, if you can maintain that level of interest by having these small structures to make sure people are learning continuously, and there's a small goal next, there's another goal next, right? Then that value, Achid, Nilay, everyone like then go and tell their friends, right? Like we are not actively doing anything, to be very frank, right? We are just learning, and there's some thought process in terms of why we are learning, what we are creating, and what we are going to do with that. And I think that clarity in itself gives people enough motivation to come, like they see a path. And this cryptography August was very clear to us. They say everyone loved it. They're like, we know exactly what we are going to learn on a monthly basis, right? And where it was going. So the moment I think we start adding value and we start looking at people as, okay, we have to look at their career. What's the path that's going to be for that person? And then people feel that and they tell people. Yeah.
So it sounds like it's sort of word of mouth just to get people, what is this? And then they start to explore, then then the obvious benefits stick out like a sore thumb. So it's a really word of mouth phenomena. And I would imagine too, the growing, it's used in a negative term always, but it's not necessarily negative, but the growing hype across the board in the public about quantum, and in India, for example, the investment by the government recently, and so there's a lot of broader community buzz, and by you having a good value proposition, when people cross your path, you kind of catch them. So got it. Interesting.
The government thing is a very interesting point. So we are also putting out 2 proposals to, the SPF, Emerging Technologies of India. It's a very interesting proposal. Just working on the proposal itself is very interesting.
Yeah. It's quite a bit of work. Are you aware, and I apologize, I don't remember the name of it, but do you know that quantum, that fund for quantum, I forget the name of it.
Quest, right?
No, it's, I'll talk to you later about it, but there's a fund that was put together by the guy who runs the Goldman Sachs quantum group in finance. He works there now, but for supporting groups like yourself. I'll send that on to you later. I apologize, I forget the name of it right now. But I hear, rumor has it, they are running out of money, so it might be a little too late. But I'm pretty confident they'll be getting more funding. But they do support international groups like yourself, like your group there. So in the quantum space. Anyway, anybody else? Questions, comments, please? Microphones are unmutable.
Hi, Terrell. Were you talking about Marco Pistoia? Is the guy from Goldman?
No, Will Zhang.
Oh, Will Zhang. Okay.
Yeah,
So
he and a group started a fund. I forget the name of it right now.
The Unitary Fund, maybe?
Unitary Fund. Thank you.
Okay.
Task done. Yeah, the Unitary Fund. Take a look at it, Sam.
Oh, right.
Yeah, and they actually do give money out. You know how some funds don't, they just talk about it, but they do.
Yeah, they give like $4,000.
Yeah, I'll take 4,000 if someone's willing to invest. Yeah.
And you've got some from them, or Terrell, or?
Oh, no, not me. No,
Okay.
The guys in Warsaw did, the Q World folks. If you're familiar with Q World, those guys got money. So, they're interested in community building, for example.
Oh,
okay.
Yeah. Yeah, take a look at that. Anyway, Raja, I guess you're back from dinner, Raja.
Yeah, I finished my dinner.
All right. Good. Welcome back. Anybody else?
Hi, Terrell. One question I had. Prakhar here again.
Hey.
Hi. So if someone wants to start a quantum startup, so I'm a bachelor's in computer science, BTech, and what should be the proper way? Like, should I go for the master's in computer quantum, or shall I go for the corporate research and development of companies like, say, IBM or Xanadu, where I can get the hands-on experience, and then I can think of opening our own startup, the academic way or the corporate way of getting into the startup?
Well, if you're asking me, Terrell, it sounded like you're asking me, but we'll pass it to Sam in a second. My answer to that is yes. Sam, what do you say?
She gave you two choices, and then
I said yes.
So
It's a very personal question, and frankly, and I'll turn it to you, Sam. But it's the way I handle stuff like that, for whatever it's worth, is you make yourself available for all options, and sometimes the option comes to you, and evaluate that option. That's what I do. I'm in the business of creating opportunities, and then some of those opportunities will find me, and that will be the answer to that question.
Business go to the academia or the corporate R&Ds? Which one is the preferable? An academic R&D or in corporate R&D? Which is the most preferred?
Yes. It takes a quantum computer to answer that. right? And that's what's up here. Anyway, Sam, what do you think? Enough of me.
I'll also say yes. I'll take Cuban. No, I would say you join Pawan's team, Quantum Finance team. That's all I would say.
Yeah, I mean, you know, if I may, you know, one opportunity is get involved with QCI and you know, and develop, you know, skills and develop a reputation through that. And one of those solutions, one of those options will find you.
So,
And, you know, and academic, by the way, you know, I went from industry to academics, and I can only speak for West. You know, I can't speak towards the India domestic environment there. I can't speak to that at all. But, you know, there's a profound difference. You know, as a professor, if you go academics, you're really like an entrepreneur, except much of the risk is taken out because you have a university paying your rent, hopefully. But I'm an entrepreneur at heart. Generally, I call it an intrapreneur, but because I got my fixed cost, living costs taken care of. Now you go to industry, the problem there is, you know, you are limited to being an intrapreneur. You can only be an entrepreneur within that company. And, you know, so you are kind of owned by that company. If you go into academics, at least in the, you know, non-India, you're really like an entrepreneur. So there's actually, you could actually work for a competitor if you're a faculty member of one university. You can go teach at another university, that's okay. If you work for JP Morgan, you know, you better not be working with Goldman Sachs at the same time. That's a, you know, most people don't point that out, but that's a material difference in those two paths. Which one's right for you, I don't know. But I really like, because I'm an entrepreneurial mind, but a little chicken to go all out, I go the academic route, personally. Because I don't like people telling me what to do. I like the market to tell me what to do. Anyway,
Okay.
I'm hijacking. Sam, what do you think? I'm going on mute.
You gave the answer yes. I'm giving the answer no. As in, don't go to either, come to community. Because, I mean, the reason is it's faster. Iterations are faster. The flexibility that you have on the value that you're the capturing of value of the total pie that you're creating. In the sense, if you're working for JP Morgan's quantum finance team and if you come out with an algorithm, you would make like very little money. Unlike if you're doing it outside, like then it's under your control, and community kind of takes away a certain amount of risk out of that. Yeah, so yes and no is the answer, like quantum. Okay, great. Praveen, question. Would require powerful device like blah, 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 blah. Oh man. I'll let Nilay take this question. Nilay or Sayantan or Archit.
Well, I guess it's very subjective question.
Okay.
Like
Cool.
it depends on the perspective and how do you wanna see it. Yeah.
Yes.
The way this is going, I think the next question is gonna be about the multi-universe theory.
Yeah.
Yeah, like then it will be like a science debate rather than propagating about quantum.
All right.
Daryl, I had just one question. Like I'm actually a final year undergrad in electronics. So I had this one question which had shuttling answers all the time is when you pick a master's, like with the people are waiting for the quantum revolution 2.0, is it worth taking up your master's in one of the quantum tracks which are there by like ETH, Zurich or University of Queensland and many other like, and even in the site which is there which you posted, there are many universities offer masters in quantum. Like, so is it worth taking a master's course specifically for quantum science and technology, or rather take a course like masters in electronics where you can specialize one part in, like, because developing the hardware side? Like I had just one question and yeah.
Well, the way I would think about it is look at the resume that you would produce what I do when I consider a job change or a significant change, I actually print out a new version of my resume. Now I don't send it out, but I create different versions of my resume based on a choice I might have to make. And I take a look at that and see what that looks like. That's one tangible thing to do. But, you know, what I've been saying to folks is that, you know, quantum has this perception of being very, very difficult. And, you know, at some level it is, but, you know, it's like anything. Once you learn it, it's not that hard. So anyway, the point what I'm saying is that if you have something like quantum on your resume, or if you're a younger person and you have it on your college application, to me, as somebody who's reviewed, you know, thousands of resumes in my day, you'll stand out. You'll stand out. And that's one of the most important things when you have a resume or a CV, is to stand out in that pile. And if you have the word quantum in there, if you're going up against other people with an EE, electrical engineering degree, and you have a quantum engineering degree, you know, all else being equal, I would imagine you'll get some attention, because the perception of quantum is that it's, you know, it's rocket science. And it's very interdisciplinary. So that would be my 2 cents on that. Sam?
No idea. Not my
Like the only reason why this question settles is like how developed the quantum architecture for academic actually is, like how the course is developed. Like people are still researching in quantum and they haven't developed a fully functional computer. But if you're studying, that means like if you compare the semiconductor industry where we have VLSI and embedded systems, people are like much away, like industry is like just booming and they have a concrete academic structure for that courses. But when it compared to a quantum, like how is it, like is it a really reliable academic structures which they have?
Yes, you know, the people offering the programs have boatloads, have tons of experience. One exception might be here at Harrisburg, for example. We don't have professors who have been teaching quantum mechanics or any of that thing for 50 years like other universities do. But most of the universities I've seen, in fact, all of them, have people who are specialized in these fields. They've been teaching these topics literally for years. But what is new is that now the universities are packaging up these courses and these professors into a new package. So the components of a quantum degree in most cases are not new. These are you know, finely tuned courses. It's just that the packaging is new. That's the way I would think about it. Now, whether it's worth it or not, you know, that's a difficult question, because some of these are pretty pricey. You know, these schools don't come cheap. So, you know, that's part of your equation of whether something's worth it or not. But you know, I assure you that all evidence I've seen in talking to these people and doing the research broadly across the board on these master's programs, these are mature courses with a couple of exceptions. Indiana University in the United States, like Harrisburg, is really creating their master's degree from the bottom up. So in that case, these are new courses. But the vast ones, the ETHs and the ones that you mentioned, those are mature courses for the most part. But that said, you know, from the new course perspective, Harrisburg and Indiana University, we are attacking quantum science from a different perspective. In fact, I had a meeting yesterday and I got the green light to start to develop a pure quantum computing master's degree. And coming from the computing side, not the physics or the engineering side, which is where most programs are coming from. But there's risk there because these are all brand new courses, you know, for example. So whether it's worth it or not, you know, that's a judgment call. I believe you can always get money for education. You may have to work, you may have to look hard, but you can always get money for education if you just keep plowing away. So I don't know if that's of any value, but.
Terrell, I have a question. I'm Shantan, by the way.
Hey.
Yeah. So you just mentioned that at Harrisburg, you've been creating a course which tackles the problem from the quantum point of view, instead of from a physics or engineering, as a physics or engineering course. And all of us have been hoping that there is a quantum advantage, but say there isn't, and a person gets a master's in quantum, then what does he do?
Well, when I pitch my programs here at the university, that question does come up. And in conferences, it comes up too. And I say two things. One, I don't care personally. I don't care. I'm not taking a bet on quantum. I'm confident that quantum is going to move forward. There's two reasons. One, follow the money. Governments are increasingly putting money into quantum computing. It's much like 1960s in the United States, where it was the United States versus the Soviet Union in the race to the moon. Had nothing to do with, there's no science on people walking on the moon. There's very little. But the whole idea was it was a geopolitical contest, and we are at the very beginning of that geopolitical contest. Not just the United States and now China, but also India's in there, UK's in there, other countries as well. So whether the technology works out or not, it is working right now in some areas, not necessarily computing per se, but money will be coming into this industry. Second of all, it's like having a degree in rocket science, right? What that signals to an employer is you're a smart dude or dudette. If you're trained in rocket science, there's a lot of other things you can do. And I think that quantum has that same aura around it. If you can do quantum computing, you could do practically anything else. Maybe not sing or dance, but your brain has lifted heavy weights and you've proven yourself. So that's my argument. It doesn't mean that you're specialized in quantum itself, but quantum computing in particular changes the way you view problems and changes your perspective on how to solve problems. That's what attracts me to it. I'm learning a whole new way of looking at problems and thinking about different solutions. I find myself when I'm doing my COVID walk every day now, I'm starting to think about problems from a quantum perspective, and that is probabilistic or stochastically versus a probabilistic, stochastic versus a deterministic perspective. Right? In classical computing, we basically have the brute force method to solve problems, optimization and stuff like that. There's some math tricks, but quantum's making me think completely differently about things. And that alone, that's what I say to our people internally at the university. We're training young people to think differently than the rest of the world does. And I think that's a win whether quantum computing fails or not.
I believe the same as you, that a person trained in quantum is equipped with the mental capabilities to attack any kind of problem. But a major problem with employers in India is they value already present knowledge in the field in a person much more than his capability to learn. So that might not be the case outside, but I would like to point that out.
Understood, but you don't want to work for people like that.
Yeah.
All right.
Most people here are like that. So
that's an idealistic view of the world. Yeah. But there are people out there who hire smart people.
Yeah. Definitely, so I agree.
If you've got your credibility, brains, you've lifted 1,000 pounds, somebody will hire you. It may not be the exact job you want. You'll probably find a better one.
Right. Thanks for answering the question.
Sure.
Hi, Terrell. This is Archit here.
Hey.
Hi, Terrell again.
I'm going to turn. This is about Sam.
Hi, Sam.
Oh, hi, Sam.
We're going to meet again at 10 p.m. today. So Terrell, actually, I am kind of in a dilemma right now. It is a pretty weird question that I'm going to throw up. So personally, I'm a science-oriented student, and I love to do research and learn about things differently. So personally, out of my like interests and all, I wanted to pursue a master in like say physics or quantum computing. But because of my current family's financial conditions, I'm not able to do the things that I want. So the next logical thing goes is to do a job. So now when I try to find jobs that are in line with say quantum computing, say in the field of quantum finance that JP Morgan or Goldman Sachs is doing right now. But the hindrance that comes, which is of a major I say significance, is that in their specifications, they say that we require a master degree or a candidate who is pursuing a master or a PhD. So what, like, I am kind of stuck in a position like from where I cannot take another step. Like, I am really thankful to Quantum Computing India, which is like helping me a lot to
Yeah.
explore the industry perspective. But if I like say just want to in future, say in the coming 5 years, if I want to pursue a master, so I just want to build a financial background for myself by pursuing a job in this field. And I just wanted to be it in line with the quantum computing domain. So I just wanted to know, like, are there opportunities? Like you were saying, there are prospective employers over there who like value the right talent. So how to find them? I just wanted to know about that.
I find that when I send a resume, you know, I've got 2 PhDs, 2 doctorate degrees. I got credentials that are pretty decent. And I'll send 200, I'll fill out 200 applications and I'll get a response from maybe 10 of them, and maybe 5 of them turn into an interview. So first of all, you know, one of the things that many don't do is, you know, you got to really submit a lot of applications. It's a numbers game to find, you know, it's like trying to, well, it's a numbers game. And, you know, I easily could get frustrated sending 10 resumes out and no one responds. And I do. But I figured out early that the response rate is really small. Even, you know, even if you're beefed up on credentials, sometimes too many credentials can scare people for some reason. I don't know why, but it does. So, you know, you got to be careful about looking for one particular job, you know, applying for it, actually going through the process to apply and not getting a response. You know, that is, I know it feels terrible, but, you know, literally when I moved back to the United States, it was 200 resumes I sent out, 200. It was 200. I'm not exaggerating. The second thing is there are for jobs, you know, I don't know the India market at all when it comes to that, so I can't speak to that. But what I do see, I maintain a database of jobs in the quantum field for Oak Ridge National Labs. There's a weekly newsletter, and we post all those jobs on there. And there's increasingly more and more jobs on, in fact, I can just show them to you if you want. Give me a second here.
Maybe just quick question.
There's more and more that are non-PhD is the point.
I have a quick question. How do you get these jobs? Like, do you run some crawler or something? Do you run some web crawler to aggregate the content?
Well, the most productive one for quantum jobs is use Indeed.com. But I get hundreds of emails every day, and I actually do look at them. So I have a lot of feelers out there in a lot of places, and so I collect the jobs that way. But the best bang for your buck, if you want to get a sense of jobs, is Indeed.com. at least in the United States, that has become the go-to place for quantum jobs. Here, I'll share my screen here. I'll show you what I mean. So this is our internal document for how we prepare the weekly newsletter. And these are the jobs that just appeared last week in quantum. And I have them in yellow because I'm preparing to move them into, last week's session. But I'll just walk through this quickly. These are bona fide open job requests for quantum people, Rigetti, Xanadu, IBM, of course. These are ones for postdocs, so these are with the PhD. Okay, ignore those. But then there's lots of other internship ones. IBM, JPM, if you're interested in finance, they have a summer associate program. It's generally meant for the younger folks, in their 20s, but apply anyway. So these here are just internships. IBM by far is hiring big time. And as you know, IBM in India, right, they just had some corporate action this week where they're doing a spin-off and such. I don't know the details of it at any great length, but IBM clearly has India on its radar. So I would definitely be looking at IBM if you're interested in the IBM market. But beef up your resume, go through Sam's program, the QCI stuff, and I think you'll separate yourself from the pack. But it's Indeed.com, so let me just now, as a foreign national in the United States, you got some complications, obviously, especially in this environment right now. I mean, people aren't moving, but yeah, I mean, it's not, there's no easy answer to finding those jobs, but beef up, while you're searching for jobs, while you're submitting those resumes, take definitive action to add things to that resume. Like, Archit gave the talk at our meetup a couple of weeks ago. You got to do that in a lot of ways, but you're really building a story, building a case that says, I'm not like everybody else, and I am doing activity. I'm not passive, and that sort of thing. That's what generally employers want, generally. But yeah. Yeah, here, look, you can see it. I think I still have the screen still shared. Quantum information, a search for that has 518 jobs, new listings. I think that's a little high, but let's just see what it looks like.
Okay.
Yeah, Oak Ridge. Well, anyway, so also the last thing, if I may, on my ramble, as the industry moves forward, and I heard people talking about it at a conference yesterday, more and more, the industry is starting to make the turn to start to be looking at non-PhDs. So their natural thing to do now is to start to look at master's level, and what they're going to find, there aren't many master's level out there. So that they're just starting to make the turn, because it's a new industry, right? And you're inventing things. PhDs are trained to create new knowledge. And so we're in the phase where new knowledge is critical to a company. As we start to make the turn where new knowledge isn't necessarily the critical component to be successful, that is how to use the new knowledge, as we make that turn in the industry, that's what master's programs are for. They're designed for not creating new knowledge, but utilizing the new knowledge, the leading edge information. And that I see the industry just starting to make that turn. It's starting to pop up in conversations. And so right now it's probably pretty difficult to get a job if you have a master's degree in quantum, but that is going to start to turn. So we want to go where the puck is going to be, not where it is right now. So be looking, a year or 2 or 3 in the future. There'll be more jobs in the masters. I can almost guarantee it. So, look at these. Visual designer on the quantum team. IBM was looking for somebody in the quantum team, an event planner. So they're looking for IBM, especially because, they're bulking up, but they are hiring more and more quantum related people doing different types of jobs. I don't know if that responded to your question, but
yes, there are definitely like it was really detailed.
Yeah. All right, folks. Sam had to drop off, so we said goodbye in the chat there privately. But anyway, let's call it a night. You guys have dinner coming up, or some of you might have missed dinner. Thanks for coming by today. Let me just end here. And any last minute comments or questions or things to get out there? Let me stop sharing. Okay.
It was a great session, Terrell. A
Oh.
lot of information gained.
Oh, great.
Thank you.
Great. Thanks for coming by. All right.
Thank you, Terry.
We'll try. I'm trying to get more. Thank you, Archid. Good to see you. Trying to get more attention to the India story. If you notice, most people look like they're from the India Nationals today, which is kind of a disappointment. So I got more work to do on that because, you guys as a community out there are doing a tremendous job. And I think it'll be, the more we can get your community recognized, the easier it'll be to get recognized when a CV comes across from you guys. So anyway, more to be done. Have a good evening. Thanks for coming by. We'll see you next time.
Thank you. Bye-bye.
Bye, Terry.
Bye.
Thank you.